Hey, Erin.
Hey, Tim, what's up?
How do you use machine learning and the cloud to be the laziest bird watcher in history?
I don't know. How do you do that?
Simple. We'll show you today with AWS recognition, AWS Deep Java library, a webcam, lots of scrapped Python code, and a whole bunch of my tears.
All of Tim's tears. Hey, Tim,
What's up?
how many pigs does it take to light up my life?
I have no idea.
One, but it's not just any pig. It's one super special metal microcontroller robo-pig. And find out how I accomplished this if you stick around for our next episode of IoT All the Things.
Special Projects Edition.
Project. Hi, everyone. Welcome. I'm Erin McGill. I'm a solutions architect here at AWS. I've built my career around the infrastructure side of the house. So first I started off as a sysadmin, then I went into automating infrastructure and deployments. So I really developed my skill set around automating and productionalizing workloads and infrastructure. So while I have worked on larger IoT projects, I'm really newly interested in home side projects that I can do for myself. So I'm really interested in diving into, how can I start with a piece of hardware, maybe a breadboard, some wires, and a little bit of code and actually make something physical happen. What about you, Tim?
Hey, I'm Tim Madison. I'm a partner solutions architect for IoT at AWS. Started out my career as an embedded developer working on firmware, and then moved into application development. And I've always had an interest in tying the real world into the code that I develop. It's really fun to either gather data from the real world or trigger something in the real world to happen. So I've always wanted to do, and I've always been doing side projects for myself. And now I get to do it with partners at AWS building different IoT projects. But yeah, on this show, we want to be able to show people these side projects and how they go from idea to fruition and edge to cloud.
And so today we're going to take you through some projects that Tim and I have been working on at home with a little bit of hardware involving animals.
Yeah, so stick around through the live stream, and we'll have special segments in the timeline below where we'll cover all the tricks, as well as the challenge of things.
Challenge of things. All right, so let's get to it. Recently, I think it was this week or last week, AWS released some information around ReInvent. I know a lot of people were waiting for news on that. Turns out this year it's going to be virtual and free, which is great.
And 3 weeks long, November 30th to December 18th.
So this is really exciting. I know that, the cost of getting to ReInvent and also the cost of actually attending ReInvent can kind of be a hurdle for some people. So it's nice to see that it actually will be free this year.
Yeah, it'll be cool to see everybody able to attend all these different talks. And like I said, it being 3 weeks long, there's going to be tons and tons of content. And you'll get to check it out from wherever you are.
Yeah, so we hope to see you there. All right, so Tim, let's start with your project this week. What exactly is it?
Okay, so what I came up with this week was the Bird Spy, and we have a video of the setup here. So let's bring up the video.
To the videotape.
Bird Spy in action. It'll come up eventually. There we go. So there we go. There's an acrylic bird feeder on my window.
Oh, wow.
And you can see through all of it. And I mounted a camera.
Oh,
yep,
cool.
It's got a hole through it where the bird can kind of sit, and you can take cool pictures of them. And this is the view you get from the camera. And I couldn't have planned this better. This was the very first time I recorded this. A bird landed right in the middle. Oh my gosh.
Oh, that's amazing.
So that's what the camera sees. And
oh, wow. Yeah, that's awesome that you actually were able to see that in action. Okay,
yeah, totally unexpected there.
We now see what your project is. How did you envision this project actually going? So, because it sounds like a daunting task.
Yeah, so like I said, I wanted to be the laziest bird watcher in history. Like that time I managed to catch a bird right there. But I wanted to have the computer do most of the work for me. I wanted to
of course.
make sure that I didn't have to sit there all day and watch out the window, but get cool pictures of the birds. And yet it did start out as a daunting task. When you think about like the high level concept of the project is, I'm just going to build a computer vision system that tells me, that sends me pictures of birds when they land.
Yeah.
But
Computer
the
vision,
whole point,
of course, seems super easy.
yeah, I took a computer vision class in college and it was not easy. So, I looked at that and I said, okay, even if I can't get it working, let me just break it down into pieces and see if I can get all the pieces built and kind of tied together. And if I get stalled at some point, I'm still going to learn something. So I came up with essentially 4 steps to get the project working. Yeah, I tried to keep it simple. So number 1 was obvious: capture the image.
Yeah, that's kind of core to your whole thing, right? Well, besides luring the animals or the birds.
Right. Yeah, I have to give them the tastiest bird food to make sure that they choose my house over the neighbor's house. So capture the image. Seems super basic. Step 2 is then detect motion, because I don't want to take every single picture. I don't want to have like a permanent video stream. I want to just get notified when there's a bird there or when something's there. And then I wanted to send the images to the recognition service to figure out if it is a bird or not. So if there's motion, take the picture, send it to recognition, and let me know if it's a bird.
And that's one of the AWS machine learning services that we have.
Yeah, AWS recognition, you can send images to it, you can send video to it, and it will just send you back the predictions in a JSON format. So it's really easy to work with.
Very cool. Very cool.
So then I said, okay, if I can get that to recognition and recognition can tell me that there's a bird there, I can scan the structure it returns to see if there's a bird, then just store the image and the predictions in S3 so that I can look at the images later.
Easy. Okay. So how did you get started on this project? Sounds like you would probably start with getting the images. Involves a camera?
Yep. So I had a Pi camera lying around for a long time. I meant to use it for a project years ago. When the Pi camera first came out, it wasn't quite as easy to use as it is now. So I started out with the Pi camera and the Raspberry Pi 4. But if you'll notice from the original video, that's not what I ended up using at the end.
Doesn't quite look like it. What did you move on to?
Well, we'll get into why I moved on to those different things, but in the end, I used a Logitech C920, which is a UVC camera.
And that's that camera right there?
Yeah, that's the camera in the middle of the frame there. So UVC is Universal Video Codec, and it's a standard that people have used so that you can build a webcam or build some kind of camera, and all operating systems like Linux, Mac OS, Windows, they have default drivers for it. So you can just kind of plug it in and it works. So I used that, and I used an OnLogic ML150G, which is a Core i5 industrial PC.
Cool. So do you have an image of like what your setup ended up being?
Yeah, you can see I got an image of the 2 things there. On the box on the box on the bottom is the fanless industrial PC from one of the partners that I work with, and on top is the C920 camera. Yeah.
Okay, so that's kind of what you settled on. So what's the flow now? Now that you have settled on your kind of camera spy thing, then I'm guessing you have infrastructure, because you have to like figure out how to get the images from your camera into the cloud. So do you have a flow? Can we? Oh yeah. Oh, there's a flow diagram. Great. Can you?
Yeah. Here's the architecture diagram. Sure. Yeah. So the center box is this OnLogic box that I have, and there's a Java application that has 2 threads in it. It has one thread that reaches out to the USB camera and just captures frames over and over again, and then it has a second thread that passes the images to this deep Java library. Deep Java library, again, we'll get into this a little bit later, but one of the problems I ran into was that the motion detection was more difficult than I expected. I know that there are libraries to do it, but a lot of the code that I found to do it just didn't work for me. So instead,
but also you have like a clear actual bird feeder, unlike like maybe a dark one. It would be a little bit easier to kind of focus on where you're looking at the action from.
Yeah, that's true. Even in the background, you can see there's a bunch of trees and things. So even when I had a motion detection algorithm working, I got a lot of false positives. So what I said was, there's this deep Java library that I've used before. I've worked with that team on their webcam demo. I said, why don't I use that? And what I'll do is I'll do 2 steps. I'll do a prediction locally and see if DJL thinks that it's a bird. And
Mhm.
then I will send the request to recognition to kind of double check, like, does recognition believe it's a bird? And if they both do, then I send the recognition and the DJL predictions to S3 along with the image.
Oh, cool. So we actually have a question from Joe Mocode. Is there a bird model in recognition, or did you have to train it with your own data?
There is, by default, when you just send it to do to recognition to recognize the image and return these labels back,
Mhm.
not only does it have birds, but it has the exact names of birds. So the first time I used it, I don't know if it was the bird in that video there, but it came back and said high confidence that it was a bird and high confidence that it was a finch. So I was like, wow,
Oh,
okay,
cool.
there's really basically nothing that I need to do now. It was pretty awesome.
That's amazing. So how do you even get to see these pictures? I mean, you're sending them into the cloud, but it sounds like it would be really cool to see them too.
Yeah. So, they're sitting on S3, and I have a separate process that's not in that diagram that goes to S3,
Mhm.
pulls out those images, and sends them to a digital picture frame I have. And we have a short clip of
Oh,
that digital picture
oh
frame
yeah,
with
let's see it.
the images. Yeah.
Oh, cool. Oh,
This
there's
is
a
one of the
cardinal.
things I need to fix. You can see there's like a blue circle there from the camera. But yeah, there's a
Oh
cardinal
yeah.
there, and then it shows me the next
Oh,
picture,
cool.
whatever that bird is. I need recognition
That's
to tell
a
me what
little
these birds
sassy
are.
picture.
Oh yeah. They're always mugging for the camera. It's pretty cool.
Yeah, they always
And then
are.
there's another one, kind of just,
Oh,
so it
cool.
just keeps
Blue jay.
transitioning through the different pictures that I've captured, and I just periodically update the collection so that we can
That's
look over and
awesome.
see what was there. Yeah.
So, I mean, it looks great, but you kind of hinted or very bluntly said that you had to, you kind of ran into a lot of issues when you were doing this, causing a lot of tears. So,
Yeah.
what were the issues that you did run into?
So first, I started out using Python, and everything was going great. Python has a PyCamera
Yeah.
library. Python has photo. I was able to capture images that looked great, send them to recognition. They worked just fine, but I didn't have the motion estimation going. And
Mm.
aside from that, I started running into these weird issues where it would work when it was on wired Ethernet, but didn't work when it was on Wi-Fi. And it turns out
Oof.
that the power supply was having issues, which was very difficult
Oh,
to debug.
weird. Oh, that must be so
Yeah,
hard. I can't
yeah,
imagine.
and luckily, yeah, I want to give a shout out to these guys. Luckily, I had a piece of hardware that I was working with. It's called the ZIMKEY, and
Hmm.
it's to store private keys inside a trusted area, and it hooks up to the Pi
Oh, cool.
directly. And it's got
Oh, nice.
all this tamper detection stuff built
Hmm.
into it, so that if you're messing with the power supply and you're trying to like trick this thing into exposing the keys, it will turn
Oh,
off. So it
yeah,
has
that
a
would be
blue
a
LED
way
that's
to kind of
blinking on it.
fiddle with it.
Yeah. So you can like exploit some of these devices by messing with the power supply. So this blue LED blinks when the device is operating normally and then turns off when there's problems with the power supply. So I just happened to have that plugged in and saw it turned
Oh, wow.
off. And in the middle of debugging, I was like, okay, I need to start, ripping things apart and using a better power supply. So
Mhm.
Scott, Phil, and Bill, thank you for putting that feature on there. It was very helpful.
Amazing. So you went from, you talked about at first talking about the Pi camera, but you then ended up going for another camera. What happened there?
Yeah, the Pi camera, it has a flat ribbon cable and it plugs directly into
Hmm.
the board. So if you put the camera
And
somewhere,
it's
you have
like
to put it with the Pi.
this long.
Yeah, it's pretty short. So you have to put them very close to each other. So you have to mount it with the Pi. And just mounting it was problematic. So I said, you know what? I have these Logitech cameras. I've used them before. Let me just use them and use UVC. And presumably with UVC, it'll be really easy to get the video out of these cameras. So
Okay. So
I
now you
found
moved
I
to
found
the
a Python
UVC
library.
camera. Hmm.
Yeah. So I found a Python library and was like called PyUVC. I was like, great. Okay, I'll just be able to capture the frames.
Perfect. Not so perfect, apparently.
Not so perfect. So the PyUVC library, again, I'm not really a Python programmer. I do write a lot of
Hmm.
Python code, but it's not like what I do every single day. So
Hmm.
PyUVC, it doesn't have the normal like pip installer. So I had to install it manually.
Okay. Oh,
And
no.
I
That
think
sounds
it was
like
developed with
fraught with
Python
danger.
2. Yeah, I
Yeah.
think it was developed with Python 2, and I was using Python 3. But long story short was, I got it working, and I had it on
Oh,
one
yay.
Pi, and
Triumph.
then
Woo.
yeah, but then I moved it to another Pi and forgot to do that setup procedure, And when it installed the dependencies, it installed a different library called UVC, which broke everything. Like nothing even worked at
Oh
all anymore.
no. Oh
So
no.
that wasn't so great. Yeah.
Boo. Okay.
Yeah.
So so you then, I guess, had to go to your next camera. Is that correct?
Well, so then I switched to the Java code that I had worked with
Oh,
the
okay.
DJL
Okay.
team.
Right. Okay.
And I started out, just every time I needed an image, I would turn the camera
Mhm.
on and try to grab an image.
Okay.
But DJL kept telling me that it couldn't detect anything, even when I was just like pointing it at a picture of a bird. So I thought, okay, something's wrong here. And then I found out that the issue was that I was turning the camera on, and when the camera turns on, it has to autofocus, it has to auto exposure adjust and do that stuff. And it takes a few seconds. So if you turn it on and then turn it off immediately, turn it on, capture a frame, turn it off, every time you capture a frame, it's going to be super overexposed. So what I had to do was just make sure that I left that camera object open. So I had it in the local scope of the function, and then I had to put it in the global scope and say, leave it open, let the camera adjust. And that's a common problem. It's like if you need some kind of hardware, if you open and close it over again, you can see weird problems. So sometimes it's better to put it in the global scope.
I ran into that same problem when I get into my project. Same thing.
Oh, yes. Yeah, it's super,
global versus
super common.
local scope. I mean, I'm not surprised. Okay, so now you were able to fix that, I guess, all white exposure problem.
Yep, I started getting images out, and I was like, man, this is why I use the Pi camera, because the Pi camera looks so good, and these pictures look terrible, and I couldn't figure out why. It's an HD camera, and then what I realized was the Pi camera's default is take a picture full frame, like full quality, and in this library, the default is to take it in SD resolution. So it's, the tyranny of the default. You start it up and you capture an image and it looks terrible. Yeah, you
That's
think.
Gonna be a t-shirt.
Yeah. I love that. I love that phrase because it really is like if you don't realize that there's some default that you need to change, you can just make the wrong decision. And I chose to use the Pi camera because the default images I got out of this camera were no good. But turns out you can just change them. I just had to dig through the docs a lot to figure out like how to set the resolution. And once I did, the pictures look great. So there was no problem there.
Great. So, okay. So you were able to dive in, fix that resolution issue, and then the images were perfect, right? Clear pictures of beautiful birds landing lightly on your bird feeder.
Sort of. I wish it was that easy. The next issue that I ran into, and we're still not even done with all the issues, but the next issue that I ran into was focus. Like I said, the camera does auto exposure, does autofocus, but the autofocus doesn't have any control. Sometimes you can say like only autofocus in the center, or only autofocus in this range. But I couldn't do that. So every once in a while, it would take a picture and it would just be sharply focused on the tree in the background instead of the bird.
Oh,
so
but you're really spying on trees and your neighbors, right? Instead of
right, of course, yeah. But unfortunately, I couldn't figure out a way to lock that in just yet. I think that there is a way to lock the autofocus. It's a little bit more complicated, but there's two problems. The autofocus isn't locked or isn't like limited to a range. And even if I could lock it to manual focus, the minimum focal length of this camera is a little bit longer than where it is in the window. So I have to find a way to mount it a little bit further back still. I haven't gotten there yet.
Okay. Okay, so but it sounds like you have the pictures taken at least, and you're going to figure out the focusing, and everything else was super easy, right? Setting up Wi-Fi on Ubuntu.
So this was the most hilarious issue that I ran into. So I went downstairs and I don't know if I should say this, but I was using some choice language because things weren't working. And my wife asked me, what's going on? And I said to her, and I talk to her a lot about technology, so she understands like all of it. And I was like, okay, I have the video capture working. I have local machine learning working. I have cloud machine learning working. I'm sending images to the cloud. I can get those images and send them to the digital picture frame. Everything works. I just can't configure Wi-Fi. And she looked at me like, that seems like the easiest part. And I was like, I've been working on it for an hour and it doesn't work.
I have to say, I've set up quite a few Ubuntu servers in my day, but they've all been servers. They've all been either rack mounted in data centers or virtual machines in AWS. I actually can't think of a time when I had to deal with Wi-Fi on Ubuntu. It's always been hardwired.
Yeah, I have almost the same experience, with the exception being the Raspberry Pi, but the Raspberry Pi's got a pretty clearly documented way to do it. You create this file in
Yeah.
the boot partition, and when it boots up, it does all the setup for you. It's great. In Ubuntu, I used to know how to do it. And when I opened up the files to do that configuration, there's this message there that says, this file isn't used anymore. You need to learn how to use NetPlan to set up your Wi-Fi. And NetPlan itself isn't complicated, but there's a bunch of things that you need to know in order to get it going. You need to know the name of your interface. You need to know that you have to run this generate command and then this apply command. And after trying a bunch of things, you sometimes get the system in a state where you have like multiple competing things trying to fix an issue. It just didn't work. So I had to blow everything away and just start from scratch. And I finally got NetPlan working, but I would say that part alone took 2 hours end to end to get working.
Definitely. Okay, so you also mentioned you're using the Deep Java library to do some pre-ML.
Yeah. Instead of doing motion detection,
challenges there with the model.
Yeah, so the Deep Java library built by the AWS team, it's really designed because there was no libraries for Java to do machine learning. I think in TensorFlow you can, but in general, like most things are focused on Python and a few other languages, but mostly Python for machine learning. So they came up with this system to do it, and they keep baking in all of this automation to download dependencies and do things automatically for you, and it's great. But awesome. I ran into 2 problems, which are not their fault, but 2 problems.
Not their fault.
So I tried.
This time we're not throwing them under the bus.
No, definitely. Like without DJL, I wouldn't have been able to do this project, and it worked out great. But there were 2 issues that I ran into. So I tried using it on the Pi, and unfortunately, it doesn't have support yet to pull down the specific Raspberry Pi binaries, so it doesn't work. It gives you an error that says you're using the wrong architecture. So I said, fine. I got an Intel box, and I loaded everything up on it. And it gave me a similar error, and I couldn't figure out why. And then I realized that the box I chose had a Celeron processor that was missing one set of instructions called AVX2 that the precompiled library needed. And I knew that just by luck. I knew that this library used AVX2, and then I just happened to remember that the Celeron didn't support it. So I had to switch to that box that you saw, the ML100G50, which is a Core i5, and Core i5 supports all those things. Once I did that, it was smooth sailing. Like you tell the library, I want to do object detection, and I want to get a predictor, and it gives you this object, and you just pass images to it, and it does everything for you magically. Downloads the dependencies, downloads the library itself, the model it needs. It's really incredible.
It sounds like you would agree with one of our commenters, Robert Tables, saying obscenity-driven development, my favorite. I think we're both with you there. I think everyone who goes through the roller coaster of emotion of development definitely has some obscenity-driven development in there.
Yeah, the obscenities helped me vent just enough to gather my thoughts and get things working again. By the way, Bobby Tables XKCD comic, awesome. So I really appreciate that comment for the content and your.
But I do love little Bobby Tables XKCD. It's a good one. And somebody, David Vasandani. I'm sorry. I butchered that. What's the name of the anti-tamper device for the Pi?
Oh, it's the ZIMBIT, ZYMBIT, ZIMKEY, ZYMKEY, 4i. Okay. And it's not specifically anti-tamper just for the Pi. It's got anti-tamper for itself, but you can hook it up with case switches that will detect tampering of like opening the Pi case. And it's designed so you can put a private key in there, and you can use that private key without exposing it to your applications to authenticate to different services. And actually, we have support for that in Greengrass with this particular piece of hardware, and we also have support to use it with the AWS command line interface, so you can have your credentials stored in hardware and not exposed to the applications. So we should probably provide some links to that when we get the code up for this episode.
Oh yeah. Okay, so what did you learn through all of these trials and tribulations, besides being resilient and just to keep on trucking, really?
Well, everything started off so easy. So I was kind of just coasting at first. I was like, this is going to be no
Yeah,
problem.
super easy. This
But
is awesome.
then,
I remember when you first started talking to me about this, you're like, Erin, oh my God, it's been so easy. I have like 5 lines of code and it does everything. And I was like,
yep.
wow, it's kind of awesome.
Yeah.
No.
Well, once I got into the different positioning things and switching to UVC, yeah, everything kind of broke down. But I'd say the biggest takeaway for me was when you're using the Raspberry Pi, if you use the camera or if you use USB devices or if you're using Wi-Fi and you're doing some type of like high compute task where the CPU is very, very busy, make sure that you have a really good power supply. Make sure you have specifically a 5 volt, 2.4 amp power supply. If you use anything less, like some like cheapo phone charger,
Hmm.
it's not going to go well for you. Eventually, it's going to fail. But there is a
Okay.
way to identify that.
Yeah,
There is a way to
avoid
identify
weak
that you're
phone chargers.
yes, yeah. I found a phone charger that I was using at first. It was like 0.5 amps, and the Pi would boot up, and as soon as Wi-Fi turned on, it would reboot. So
It's
avoid
like, no,
those.
thank
But if you have a Pi that's being flaky, and it might be
you.
because of these problems, before you go and change your charger or your power
Mhm.
supply, what you can do is you can run dmesg, DMESG. I'm
Ah,
sure you've used it
yeah,
before to
right on
check
the command
kernel
line.
messages. Yeah,
Everyone
so
loves that.
yeah, the Pi has this notification that says under voltage. So if you see this under voltage warning, or if you're experiencing flakiness, run DEMESG, check to see if you're getting under voltage. And if you are, turn off Wi-Fi, disconnect your USB devices, get a better power supply, and then see if that helps. If you need to use Wi-Fi, just make sure you have a good power supply. But otherwise, if you need to use USB devices, don't hook them directly up to
Mhm.
the Pi. Use like a powered USB hub, and you'll probably be in better shape.
And turn off everything that you don't need.
Yeah, yeah. I mean, even disable the camera interface if you're not using it.
Oh, okay. And it sounds like were able to work with a new library. I mean, it sounds like you had worked with them before, but actually you got to apply it to something practical that you used at home.
Yeah, yeah. So I made some modifications to the DJL demo repository on GitHub to support like a little bit easier integration with webcams and cross-platform support. So I had worked with it
Mhm.
before, but just very basic. And this time was the first time I got to take what they've built and put it into my own application, and uh, it was really pretty easy to use. So if you want to do some kind of machine learning, if you're a Java developer, it's definitely the natural choice. Even if you're not, though, it might make sense to make or to use DJL to do your predictions and then provide an interface to a Python function or Node.js, whatever you use, so you can avoid all of that setup. Just let the library do it for you. That's how I like to operate.
Okay. And so let's see. So what's next? Want to do?
Um,
You talked
yeah, I
about
think
some optimizations.
Yeah, quickly, the only thing that I have right now on the schedule for this project is optimization. So when I take a picture, I send it to recognition, and if it recognition says it's a bird, then I send it to S3. And I want to avoid sending the image twice because the images are kind of large. So what I want to do is I want to use S3 event-driven actions. So basically S3 event notifications. I want to put the file into S3 and then have recognition do its work in the cloud, so it doesn't need to transit my network twice. Um, and then we've got a thief in our neighborhood. We have a squirrel, I think, that's stealing our tomatoes. So I'm going to repurpose this to try to catch the squirrel in the act to make sure it's them, or a raccoon, or whatever it is that's out there. So those are the next two things for this project. So
Yeah,
I would say
to
stick.
see who's so rude about
Yeah,
taking one bite out of a tomato and then just like dropping it, and then taking the next
yeah,
one
they
and
eat
then just dropping
half the tomato and then they litter. They just leave it on the ground, like wasting food
it.
and littering. Two things I can't stand, like all in one. So,
Jeez,
animal kingdom.
I
Anyway,
know.
so stick around until later in the stream. We're going to have a bird spy related challenge for the viewers. So, this will
Mhm.
be your opportunity to show me up and contribute to the show, which should be cool.
Yeah, that'll be awesome. Maybe somebody could tell us how to show you up right now. So leave a comment in the stream if you have any ideas. Um, yeah, okay. Thank you.
Cool. So, Um, I believe that you also now have an animal related project. Can you tell us
I
what you got?
I do. So I don't want to turn this into, Lights Are Us show, but I did another lighting project, but I expanded it to include capacitive touch in one of my favorite possessions. Oh, of course. There we go. No. Okay, my light. My
Oh,
pig.
there you go.
My pig in my light. So, yeah, I was able to rig this up so that my pig, touching my pig, will turn on and off my light. But as
Nice.
you can see, it's a work in progress.
Sure, yeah. Oh, I mean, always. Everything fails all the time, right? So,
Always.
yeah,
Of course.
when you showed me it yesterday, it was working like perfectly. So, there's a lot of variability in there. So, I love capacitive touch. My parents had a
Hmm.
capacitive touch lamp that I would like mess with until I got in trouble when I was a kid because I was fascinated by it. What got you to decide to do capacitive touch?
Well, like you, I find it so interesting. And actually, it was one of your projects, the one that you talked about, where you did the Bobble Head of Werner and you touched it and it said, everything fails all the time, which we all know as a truism. And I
Yep.
was like, man, that sounds so cool. I would love to do that.
Cool. So
Hmm.
did you when I did that project on the bobblehead, which I have here, keep it on my desk
Oh,
with
there
his
he
encrypt
is.
everything shirt. Oh yeah, it's out of
Oh,
focus, but
oh, there
that's
he
the
goes.
bobblehead
Okay.
there. Um, so when I did that project, I looked around for a component. I'm always looking for libraries to do things. I also always look for components to do things because I'm not an electronics person. So
Yeah.
I used a
You
pre-made
just play
board
one
from
on
Adafruit.
TV.
Yeah, yeah, that's it. I just play one on TV, right? Um, so did you use one of those boards, or did you go the manual route?
I didn't. I have so much like hardware and things that I've collected through the years of going to reInvent and other kind of tech conferences, and I have that Arduino board that I was using recently on a different capacitive project, but with moisture in the air. So I had that Arduino. I had a starter Arduino kit that had a few capacitors, a few resistors, some diodes in it, and so I was like, I wanted to see if it was possible to use what I already had on hand.
Nice. Okay, I like that. So, I'm like I said, I'm not an electronics person. I couldn't tell you how to design a circuit. I can make maybe minor modifications to something, but if I was starting from scratch and wanted to build something like this,
Mhm.
I wouldn't even know where to start. So, how did you know how to build this circuit? Like, what did you do?
I started with our neighborhood friendly search engine, web crawler, and Alta Vista.
Love it.
So yeah, I just
Only the
did
newest
a
ones
search.
for you, of course.
The only one. Um, so yeah, I found a few projects. They were using that board, the capacitive board, but as I said, I want to be kind of frugal. I want to see what I can do with just what I have lying around. And I finally came across a video of someone who was just using an Arduino, just like the controller that I have, and some resistors, wires, and a piece of foil, and using the capacitive sensor library. So I was like, hot darn, I think I
Okay.
have all that stuff. Plus, I've got my pig. So why not give that a shot? Um,
So, do you have a visual for us on this?
I do, and then I can talk through. All right, that's it. My very
Pig drawing,
beautiful.
awesome.
I did that pig drawing myself. I just want to say that. So I just kind of highlighted the important parts of this diagram. There's my ESP32. I'm using the pin 4 for the send pin and pin 15 for the receive and sensor pin. And then I have 300 ohm, but I actually am using three 1000 ohm resistors, so there should be an extra zero on there, but I can't spell numbers. And then you can see I have a wire coming from that, going to just a piece of foil, and my pig is standing on it. So I can show
Got it.
you. I don't. You probably can't see it, but that's what it looks like in real life. Everybody.
Got it. Okay. So that's pretty awesome. It
So
sounds like you really didn't
yeah.
need that many parts. When I looked around at first, I saw that Adafruit board and I saw it had a microcontroller on it and a bunch of other things, and I assumed that would
Mhm.
require a lot of parts. But I mean, it sounds like you needed almost nothing and you had basically everything on hand. So what was the exact parts list that you had?
Okay, so I have my ESP32.
Okay.
I have 3 wires. I have
Okay.
3 1,000 ohm resistors, some aluminum foil for my kitchen, and then a metal pig.
Okay. And people could do this without a metal pig. They could have a metal anything,
I don't know
but
why
yeah.
you
So
would
that's
want to do it without a metal pig.
right. Metal pig. No, I love the metal pig. It's pretty cool. And so
Yeah.
the pig's foot is also metal too. So you've got to have that foil
Yes.
touching a metal part, and then you have to touch a metal part, and then that's how it
Yeah,
works.
and it's all soldered together, so I don't have to depend on just like parts that are actually part of what's touching it. I can basically just touch it anywhere,
Got
and then
it.
it'll go
Okay.
on.
So all right. Do you want to talk a little bit more in depth about how it works? Because you've got this touch sensor hooked up, and you've got to be getting some type of value that you're reading, or that the library is reading. Like,
Yeah.
how does it turn that signal, whatever that signal is, into a touch event?
So in the capacitive sensor library, it uses the capacitive sensor method, and it toggles the microcontroller send pin, which you saw was I'm using as pin 4, to a new
Mhm.
state. And then it waits for the receive pin, or what I'm using as a sensor pin, to change to the same state as the send pin. And the
Okay.
variable within this loop is incremented to time the receive pin state change. So there's that difference in the time changes that is actually sent by the method as a value, as a variable value, whether I'm touching it or not. And these are in arbitrary units, so it's just kind of just a number that
Got it.
is sent by the method itself.
Okay, so the send pin goes high, and then the receive pin, it kind of like calculates how long it takes to get up to that same place, and then
Yeah.
gives you some value back to indicate that. Okay,
Right.
interesting. So if you don't use the resistors, or if you use a different value of resistors, what happens? Did you fiddle with any of those values? Because it sounds like you needed to do a lot of work of figuring what the
I
correct
did.
values in the code were, but the
There
resistors
was a
I'm
lot
curious
of
about.
just kind of like experimentation as far as resistors are concerned, since I mean the library suggested I use 100k. I ended up 100, yeah, 100k ohm resistors, and I just had very small values like 1,000. So
Mhm.
when I didn't use any at all, then nothing happened because no resistors doesn't work, because there's no
Mhm.
difference between the time change of when the send pin changes to when the receive pin
Right, the other
changes.
pin just comes up immediately. Yeah, got it.
So when I broke down and I bought a lot more resistors so I could see, okay, yeah, what does happen if I use a higher value, kind of one that the library suggests, and it turns it into a proximity pig. So it's a proximity sensor pig. So I could just get like not even touching the pig itself and it would turn on.
That is
But
cool.
knowing how much I move around, and my light would be turning on and off much more often than I probably want it to.
Got it. Yeah, I would love to hear from the
Yeah.
viewers, because if there was a way to measure how far away you are, if you could turn this into a
Yeah.
metal pig theremin, like what would the viewers want you to
Yeah.
control? Like the light brightness is one thing, but maybe music volume, you can do this like Star Wars force push, like turn the music off. I don't know. It
Yeah.
could be
Hey,
something cool.
we're all building on these new projects. So if you have any ideas for me, bring them on.
Yeah, yeah, that would be awesome. I think I'm gonna have to wire up some more stuff in my office to be capacitive touch and see if I can. I want to play with that now too. Now knowing that it's kind of like a proximity sensor as opposed to just a touch
Yeah.
sensor. Okay,
Yeah. I love
so
it. And I
you
found that by accident.
yeah, you experimented with the values for the resistors, and then you had to do some testing with both the numbers that come back and also
Mhm.
which pins to use. So how did you go through that?
Well, I actually didn't. Since I was using my ESP32 for a previous project, I didn't look at the schematic, which is always, you should always go look at it. And I was just using the pins that I already had used 4, and 15. And
Love.
then I just kind of lucked out. Because it turns out after, you and I had talked and you're like, well, what happens if you use different pins? And I was like, maybe I should go and actually look at the schematic. Turns out I just happened to, like, ESP32 is great. It's got Wi-Fi. It's got Bluetooth. It also has touch pins. So I happened to just be using pins that were touch capacitive, luckily. So that would probably explain why I don't need as high a capacitor value for my circuit.
Yeah, likely it's got
Or
some
for
internal resistors or internal capacitors that are supposed to do that for you already. So, okay.
Yeah, they sense variations in anything that holds a charge, including us as people. So they can detect the variation induced when touching one of those pins with a finger. So, it's much easier. You don't have to kind of go through with having to kind of do it with the analog digital converter pins, which I did use, and I tried. And I ended up having to use a pretty medium to pretty high value resistor. And then it was much more erratic, much more unstable. And I read that, you should put in a capacitor in line with it to kind of make it more predictable, more stable. So that's probably just what these pins end up doing for you anyway.
Okay. Cool. Well, good to know that you mentioned it to me before, but I just completely forgot that the ESP32 had it. It seems to have everything, like dual core, lots of RAM, storage, Wi-Fi, Bluetooth. It is a great chip. Okay. So what problems did you run into? What was the biggest problem you ran into, I would say?
Yeah, I'd say the biggest problem I ran into is the HTTPS connections to sending the message to the lights. So again, I found global versus local. I was actually establishing a connection every time and then sending a message, but doing that to check the state and then also send the message caused huge memory dump issues and probably a lot of memory fragmentation. So I took out the checking, still sent it. It was a problem. It also caused a delay. So each of those SSL handshakes added a 2-second delay to touching. And we all want our touch capacitive things to be immediate. So I moved it to global and it got rid of that.
Okay. Yeah, one thing I wanted to highlight, where you talked about memory fragmentation, like when you're working with a regular computer, it's not really a problem if you allocate and deallocate things. But on a device like an Arduino, if you do that a lot, you end up with these holes in the memory. And when you then try to allocate something, it's going to look and say, hey, do I have enough space to allocate this whole thing? And if it doesn't, it will reboot just like you saw. So one tip that I would give people is, if you can, and this is from my embedded development days, pre-allocate everything you can up front. Unless you really need to do it on the fly. Be aware that fragmentation will cause issues like that. So now that you got it working and it looks pretty cool, what's next?
I'd love to see how I can integrate IoT core and other IoT services to possibly maybe like trigger my Alexa when I touch my pig, or maybe, make a sound when I touch my pig, or when I'm launching a confirmation stack, maybe it could oink when it's done or failed, or tell me,
that would be awesome.
whatever state it's in, it would probably oink all the time. But now that I'm thinking about my next projects, I know I'm probably going to eventually move to Raspberry Pi development. And since you've done a lot, I think you have some tricks that you can share with me and all of our viewers.
Yeah, I've got a whole new workflow for local development with the Raspberry Pi and that on-launch device. So let's get into it with all the tricks.
All the tricks. All the tricks.
So there are two things. There we go.
Two things.
All right. There are two things that I want to call out here. Is that when I was doing development on the Raspberry Pi with Python, when I started out, I would do a little development on my laptop, copy the files over, and run them on the Pi, and then copy them back and forth. And I know a lot of people do that.
Yeah.
Yeah.
But
stuff ends up getting out of sync. It's not ideal. And you can use NFS, but you have to install a bunch of stuff, and NFS I've always had problems with. So there's something that I found called sshfs, and yes, you need to install that too, but it's, in my mind, it's a little bit easier than NFS, and it uses this thing called Fuse, which is the file system in user space. So what it lets you do is take a system that you can SSH to, and this library will then kind of mount that system as a disk. So you can just SSH into whatever system, and its home directory will show up as a directory on your system, and it'll sync the changes back and forth with SSH.
Cool.
It's pretty nice.
And I know you're going to get back into Python development, whether you want to or not. So do you have any tricks to make it a little bit easier?
Yeah.
At least for developing using Boto 3?
Yeah. So one of the things I've noticed with Boto 3 is that because of the way that objects are instantiated, it doesn't always give you autocomplete information that I'm used to in other languages. So there's a project called Boto 3 stubs that gives you a new way to instantiate these objects so that Python knows the type, your IDE knows the type, and then it can give you all of the autocomplete information. So when I was doing the development on the Pi, I set up sshfs, I set up my IDE, I was developing on the Pi through my IDE, and I had Boto 3 to give me all the autocomplete, and it made it so easy. I built that first, capture and send images to recognition in probably 30 minutes, which was awesome.
That's awesome. Great. And now I think it's time for the challenge of the things.
Challenge of things.
Challenge of things. So our friend Tim here, everyone out there saw that he ran into a lot of obstacles when building his project in Python. So maybe you out there, you viewers, can implement the solution and show him and where he went wrong.
Yeah. Like I said, it started out all so easy. Once I got the environment set up.
Do we have a diagram for this?
Oh yeah, so we have the diagram. We'll show that. But it started out real easy, and I ran into all these issues. So what I'd really like to see is a similar architecture to this, but implemented in Python. And if there's a way to more easily use UVC, or if there's some tool to install that library more easily. I would just like to see somebody else's re-implementation of this, because I think that the Python implementation is going to be pretty concise, but I as not a Python expert, I would love to get people's tips about how to make that development process easier.
All right. Well, great. Thanks so much for joining us in this episode.
Yeah, check the chat stream for resources that we talked about during the episode. We'll be providing assets in the form of code and diagrams and stuff like that once we get the GitHub repositories approved.
Yep. And be sure to tune in to our next episode in 2 weeks, Thursday, August 20th. Watch for announcements. We have a full season ahead. A reminder that we're going to be looking for project experiments, not just to help Tim out, but also from edge to cloud. So send us all of your cool ideas. We can't wait to hear from you. Yes. And let us know what you thought of the show at #AllTheExperiments.
Yeah. Thanks again. And we'll see you next time on IoT All the Things.
IoT
Special
All the
Projects
Things.
Edition.